That's absolutely adorable what this program can do. So for alkylating agents, you need to know which one of them are gaseous and which of them are fluid. So for instance, glutaraldehyde, phthalaldehyde, beta-ketone lactone are liquids, and ethylene oxide and formaldehyde are gases. Okay, you need to know that. Mechanism, of course, yeah. You need to know the use. Like, what would you use the gas like ethylene oxide for? It's really good at sterilizing. Like the entire room can be sterilized. Okay. Heavy metals. You need to know the term oligodynamic. So it means that they work in the really, really small amounts, and you need to know the mechanism. They are disinfecting. For phenols, or mechanism, chlorhexidines, fine. Oh, triclosan story. So you've heard about the antibacterial soap. Triclosan was a component of it. Triclosan was a component of it. FDA, a few years ago, they recommended not to use triclosan containing soap for two main reasons. It turns out triclosan is not that good by itself, and turns out the majority of we used so much of that soap at some point that bacteria in the environment became resistant to triclosan. Okay, you may find some claims that it's toxic. I mean, the dose makes the poison, but in these concentrations that we used it in the soap, it was not toxic at all. Okay. One more thing. Okay, so here, surfactants. So we've got cationic surfactants. They're called cationic because they contain this positively charged part. And you see they have a positively charged part and a long hydrophobic tail. So they charged positively, the surface of the membrane is charged negatively. So this cationic surfactants very efficiently interact with the bacterial membrane and disrupt it. Anionic surfactants, such as soap, they have, you see that negative charge with a long hydrophobic chain. Can you see? I hope you can see the negative charge here. I just made a giant arrow towards it. Since they are negatively charged and the bacterial membrane is negatively charged, anionic surfactants are not nearly as effective in terms of disinfection as cationic are. Alcohols, speaking of which, the current infection, if you would look at this table, it compares, I highlighted in yellow the effects of alcohols on different viruses, and you can see that enveloped viruses can be fairly efficiently inactivated by the alcohol. So these numbers, the higher the number, the better. Okay, basically the logarithmic difference in terms of the virus concentration. So coronavirus is enveloped virus, so alcohol will be very effective about it. Of course, use it outside. You know, consumption of alcohol hasn't been linked to any health benefits in case of infection. Halogens, yeah, we talked about halogens, saying that it's only two halogens are used. So chlorine and iodine. Fluorine is too toxic, bromine is too toxic, and you can't really make any reasonable chemicals using this too.